So this bridge problem was there in the book. I could not solve it. Then I went and looked at the hint. Didn't help me. Went and looked at the solution also. I'm not entirely convinced with it. Yeah, I don't know what to make of it. So I thought we can all discuss and come to some kind of understanding. So the shortest distance from A to B, but across the river, it has to be perpendicular to the sides of the river, the banks of the river. Assuming it's absolutely straight. So
the bridge has to be perpendicular to the banks.
Yeah, bridge has to be perpendicular. It has to be like this. All right, it cannot be, if we take the shortest path, it would come somewhat like this, but it would not be perpendicular to the sides of the river banks. So it has to be like this. But if we just do this, then there's a lot of deviation from the actual shortest path of, if you just connect this point to this point, right? There's quite some deviation happening. Initial reaction was to take the shortest path only and just build the bridge wherever it intersects the river bank. So build it here. Build the bridge here. And then continue. But yeah, that has quite some deviation from this shortest path. And
so my intuition is, so basically we are not given like any numbers. So it is like, yeah, we are just working without numbers only. The bridge always has to be perpendicular to the banks. So that distance is kind of fixed. You can't change anything about that.
correct.
And if I have any random point on the river, there will be exactly one bridge passing through it.
Yes, correct.
So now this is my intuition only. I'll just connect A and B.
Okay.
So there is this segment through the river, right? Where that path goes through. I'll just take the midpoint of that.
Midpoint of that, huh? Oh,
yeah.
Okay. And build the bridge through the mid path, is it? Middle
Yes.
point.
Yeah.
So yeah, this is my guess.
That would be, even I agree with that, because that would be the shortest actually.
Yeah. So
Because if you if you make a right angle triangle there, that the point touching the bridge and the point A will become hypotenuse, and this average will be the shortest one, right?
So the new path would be this and this. So it would have, you're saying the increase is minimal here in this case. So the solution, I'll tell you what was given in the book. I can't even think whether it's equivalent. Is it equivalent? I don't know. So the book solution says, if you have this on a piece of paper, you just fold the paper so that the river disappears. And then draw the line from A to B. Once you open it up, so there will be 2 points, 2 opposite sides of the river where the path would actually be meeting. Draw the bridge there. That is your shortest path.
That is again you will get this same line, I feel.
We'll get the same line.
You get the same line, yeah. I'll do it now only, wait.
Yeah. So we
Yeah.
can do some.
Yeah, after drawing the diagram, it's easy to locate that point.
Yeah. Yeah. So if we were to prove it, so we'd have to show that any other position would give a distance more than.
So, by the way, this reminded me of another kind of problem where it's like you, basically you have to go from A to B. You are going in some jeep. The jeep will travel at some speed on land and it will cross water also, but it will go slower. So you have to find the path from A to B if you are like crossing from the jeep, the fastest path.
Okay.
So that will actually be the path like light travels from one point to another. If you have like a refractive, like a transparent medium in between,
Right.
the path followed by the light will be the fastest path.
The jeep is traveling slower in water, then obviously this perpendicular
Huh.
the way to go.
No. It need not be. I mean, if we are talking about the Jeep problem, this might not be the fastest path for it.
Why? If it's slower in water, then I would want to minimize the time minimize the distance I travel in water.
Not necessarily, but you will be like covering more distance on land, right? It might be the case that if you are going in some slant, you are saving it on the land speed.
Okay.
Right. So basically, yeah, I'm just reducing that river to a single line. So if I'm doing that, then the green path will basically be the shortest path. So since the bridge is, we know that the bridge is perpendicular. So it is like if I choose the orange path, it will effectively look like this. So except on this line, it's like I am covering some distance, but I'm just not showing it.
Right.
So it's like if I reduce the river to a line, this orange path would effectively be this distance. I mean, this path, the orange path with the line over here. So
Right.
actually, in this case, the shortest path is that straight line.
Correct.
The equivalent of that over here should be this line followed by the perpendicular bridge and the remaining of the lines.
Yeah. So that folding of the paper makes sense. Yeah. But a formal proof still eludes me. I am not even able to.
So I am thinking we should probably represent this distance as the length of the path in terms of like x and y. Suppose you have coordinates for A and B.
Oh.
So we will just call it some x1, y1. And this we will call it some x2, y2. And yeah, you can give some distance for this also. So say we are calling this width W.
Yeah.
So yeah, now we will be able to like give a formula for the length of any path. And if you differentiate, you should like do that partial differentiation coming to 0. This should be the straight line path that gives the minimum. It sounds like unnecessarily complicated. I'm just wondering if there is a simple.
This was one more interesting one that I found. So on a square, draw any two lines perpendicular to each other, but all the 4 lines should cut the 4 sides. But it should not be perpendicular to the sides. Now cut along this, you will get 4 pieces, and you can use that like a jigsaw puzzle and of course reassemble the square, but along with that you can arrange it to make a bigger square with a square hole. So no matter where you choose this point and make those cuts. This is always possible. So the
Okay.
question is, so we'll take a sheet of paper, mark a random point, and draw perpendicular lines there such that all 4 lines will cut the 4 sides of the square. And also the lines will not
They
be,
intersect.
they will intersect the sides of the square, but also
Okay.
they will not be perpendicular to the sides of the square. So we won't do this, for example, we won't do this.
Okay.
It will be something like this.
Okay. Got it.
So then cut that to get 4 pieces.
Okay.
It's perpendicular to the sides of a piece, right?
Should not be perpendicular to sides of the page. 2 lines perpendicular to each other.
2 lines perpendicular to each other.
Yeah, but not perpendicular to sides of the square, but intersecting the sides of the square in, I mean, all 4 sides of the square. So something like this.
Okay.
So we will get 4 quadrilaterals like this, and we'll cut that out.
So I am able to get the
The square with the whole of it.
yeah.
Oh, okay.
Are you able to see it?
One
Can
second.
you see it?
1 second. I can see it partly. Yes, yeah, I can see it. Super.
Now I have to see why this works. So
Yeah, why it works. Also, is there a pattern to putting it back together?
yeah, I'm trying to put it back to you. So like I think I'll label the corners over here so that
I got it. How do I show this?
I will stop share. You can.
I don't know how to show this actually.
Okay.
Is it visible?
Yes, yeah. It's not very clear because background is also white.
Yeah. 1 second.
Oh, I have found something interesting about the pieces. So yeah, I'll give you time. So if you can also find it. So I am able to see why that hole will be a rectangle. I want to see why it will be a square. What are you all working on?
I am trying to see why it's a square. Like you said, I can see why it's a rectangle. Why it's a square? This seems very familiar, right? This shape, not exactly the same, but square within a tilted square within a square is familiar. But
That right angles is because that cut is, the line is perpendicular to each other. The two lines what we draw, those 2 lines are
that is
perpendicular.
coming on the corners of the big square, no? The cut that we made coming on the corners of the big square.
No. If that is a perpendicular, that went to the corners, but this when you make that as a straight line, here also you will get perpendicular, right? Inside the hole.
The right angles of the original square.
Yeah.
But that they are not forming the angles of the square, no? Directly they are not forming.
No, they are not forming the angle, but the pieces are formed in such a way that the center cut is 90 degree. So when you rotate that, again here, these lines, if you join, that also will be 90 degree. That's my...
So can you see that all 4 angles on the 4 pieces will be the same?
All 4 angles
Of the 4 pieces that we get are same. I mean, all the 4 pieces have the same set of angles.
Corners or even all the 4 angles you are talking about, Ashwin?
Yeah, so the four pieces that we have, each piece will have two right angles, and
Or
the
right
other,
hand. Yeah,
the
each
other
one
two
will have
angles will
one.
be, I mean, the other two angles, the same pair of angles will be there in all the four pieces.
Same pair of angles. Okay.
Yes.
There are two 90s, right?
So, Gauri, how did you get it to be a rectangle? I mean, so what was your?
So the exterior angles turn out to be 90 because they are from that original square. And so
Okay, yeah. So that's how I also thought it's going to be a rectangle for this reason.
but these are not similar quadrilaterals, although
Yes, correct.
That is because we can say alternate angles.
ah,
The original figure,
yeah,
when you cut it, it's alternate angles. See what I,
Yes.
yeah.
and that's why means I called one of the angle as A and one of the angle as B. So when you join them, you will definitely clearly see that they are pair of alternate angles.
Are these would this be similar? Are these similar quadrilaterals?
No, I mean, I also thought of that, but no, it's not.
Because the scaling is not linear. It's not equal on all the sides.
Yeah. So the angles are same, but it's not similar.
But it's so like, yeah, because the angles are same, it looks so.
See that line, the center line, when we drew that, when we cut this, there are two similar pieces, right? Similar lengths.
Yeah.
And here, those lengths have been overlapped here.
Okay, wait. So ABCD is the original square.
Okay.
And the center point is O. And what is E, F, G, and H?
Yeah.
So you are talking about
OH.
OH.
OH from that quadrilateral and to this quadrilateral.
I think she means AEOH.
He's saying
Yeah, AEOH in that quadrilateral, the length OH, and in DGOH in that OH.
these, right? We are talking about these two.
That's a common side.
Correct.
Yeah. That length is same. Likewise, all these are common sides.
Yes.
So you get two equal sides here.
Correct.
Yeah, those four pieces. Actually, when we reverse that pieces, because it's a common sides, here also you're getting equal overlappings.
Okay.
I cannot make out which is my OH here.
Yeah, I actually have colored my vertices so that I'll know which goes where. Can you see it now?
Yeah.
Can you move it a little bit no, towards you? Yeah.
Right. So this is the pieces after I have cut and everything. But before, so this piece, this length is same as this, and it effectively comes like this. So yeah, this way, because like I have labeled the right angles, I know which will be the corners of the new square that I have to form. Yeah. So here I think we can figure something, that is this length and this length will be same.
Because they are perpendicular.
No, those two need not be same.
Yeah, correct. They need not be same. Correct. Yeah.
Those two need not be same. I'm talking about those common lines after cutting, you're getting
Yeah,
those.
yes, you are talking about this line. I
Only
think.
that lane, yeah.
Yeah, this will be common between these two pieces.
Yeah, those two are equal.
Correct.
So basically, yellow, no.
So are any of those sides equal there on the edge of the square? The segments we've cut off, are any of them equal?
Not necessarily, I think.
Not necessarily. We can draw wherever we want, no? So
Correct, correct.
So I can see this feature. That is, if I draw this line, basically the diagonal. So this diagonal will be this square plus this square. It's also this square plus this square.
Pythagoras, okay.
yeah.
So yeah, I'm wondering if that will lead to something. Yeah, wait, I'll just try it out.
Can you see this?
Yeah.
See that common line only I did. Here and these two are the common sides in the center. And these two are the common lines of these 2 and 3. Like see 1, 2, 3, 4 I've named actually. If I keep it like this, it is like this. This is a common side.
Yes.
And now when I rearrange, that is going on the outer side, but it's going like this plus this will be equal to this plus this.
Oh, okay.
And here also these two sides are like, if I put it here like this, but the same thing is rotating here.
Oh. So in our final diagram, we have
so that center line is coming here and it is adding up here, and these two, that is the reason we are getting here square, and because of that your also sides are equal.
Wait, so now I can see that in the bigger shape that we are forming, the corners are 90 degrees. That is clear because we started with 90.
Yeah.
Now you are saying opposite sides are equal.
Yeah, because see the same side.
No, I understand the proof. So yeah, so now you are able to show that opposite sides are equal. Right?
Yeah.
That means the figure that we have is a rectangle. That is what we have proved. The bigger shape, the outline shape is having opposite sides equal and all the angles as 90.
Yeah.
So now we have so far shown that outer shape is a rectangle. We should show adjacent sides are also equal. That I am wondering if when we make those two lines, the two lines will be of same length.
yes. Yes, I'm almost able to prove it.
So why should that be of same length?
Because it's a square and you're making perpendicular lines.
Yeah.
Perpendicular, I mean, if it has to be perpendicular.
Yeah, because we are drawing perpendicular lines and the square has everything equal. So yeah.
I mean, if the lines have to be perpendicular, then they have to be equal.
No, what I'm actually having trouble because I mean I can draw. So yeah, maybe I'll share the screen. Okay, so we are starting with the square and we are drawing some random line.
Yes.
Okay, so now we are going to draw another line which is perpendicular to it.
Correct.
So it will cut. I will color this. Okay. So now I can actually draw several parallel lines. They will be of same length. Yeah.
Yes. Mark all the equal angles.
Okay. So you mean equal angles which makes along this vertex here?
Yeah, yeah.
So
That and
They will be equal only, no? If you draw parallel lines.
correct,
It moves, that line moves actually, but the angle will be same only, no?
correct. So yeah, actually here we are looking at length. So now we want to show that the red line and the blue line will be of same length.
Yeah.
Yeah, Gauri, you had a proof. You mentioned like some congruent triangles and so on.
yeah, yeah. So if you mark all the angles, mark
Okay.
all the equal angles.
You want me to mark the other like supplementary angle?
It's okay.
Ah.
Now drop a perpendicular from the top where it's intersecting the side. Drop a perpendicular to the bottom.
You mean this line?
Yes. Similarly, draw a parallel. Draw perpendicular from this other point.
Here.
Blue line. No.
Horizontal line.
Blue line should be the hypotenuse. Make a right angle triangle. Blue line should be the hypotenuse. And yes.
Oh, okay.
These two are congruent. All three angles will be equal.
Okay, let me label the vertices. So which two triangles are you talking about?
The blue,
okay.
orange, black, and the brown, black, orange. Yes, ABC. And
This you mean?
yeah, ABC and XYZ will be congruent.
Okay.
Because angles are same.
Right.
And one side is same.
Okay. Yeah.
So those two lines will be the same.
Oh, okay. Yeah. Nice. Yes. So now, yeah, we are able to prove that the outer thing is the square. Okay. Yeah. Yeah. It is like. Now, how do we show the inside thing is?
So one more thing, if you start with the original square, no, to make the big square, how are you rearranging the pieces?
I mean, you want me to show it on paper? Like, you can show it on paper.
Yeah, I mean, just try to keep the pieces and just rotate them. So does that give a hint is what I'm wondering for the, I don't know that it does, but I find this to be interesting. So keep the pieces A, B, C, D as they are to make the original square. Then rotate it such that, that inside right angle becomes the outside right angle. Do that for all four pieces. And we have the solution.
I tried it with outer rectangle and the whole inside is also rectangle.
Oh, is it?
Yeah.
Oh, nice.
I actually was like writing it down. I wanted to try later, but yeah, glad you actually did. So what did you do? You started with the rectangle and you drew perpendicular.
Yeah, I mean, it's not just the estimation, but yes, it's a rectangle inside also.
Okay.
I started with a rectangle. Now, how those two rectangles are connected, we'll have to check. But it's not square, definitely.
You think it can work for triangles also?
Yeah, actually, Shubhangi, can you show how it looks?
This is the original.
Okay.
Can you see? I mean, I can't see what you are going.
Yes. So yeah, we can see. Yes.
Okay. And now when you, as Manjula said, I tried to make this marking.
Can you move the book a little bit towards yourself?
Pardon me?
Move the book little to yourself, towards yourself. Oh, beautiful. It does look like.
It could be a parallelogram
Wasn't
or
exact, Ashwin. I just
No, why would it be parallelogram? Because the same logic holds, no?
But-
There are right angles making the external angles.
measurements were not exact, so probably
I think that logic is still the same. So the vertices of the initial thing is now becoming the external angle of the whole.
yes.
So it should be
I
rectangle.
used that technique here, and I matched the to make that straight line, obtuse angle and acute angle together.
Oh.
But I don't know what's the use of these common part. I still didn't get that part. See, I marked it like this, but they are not matching anywhere.
They are matching, no? I mean,
Yeah, they are matching, right? These two are same, these two are same.
Ah,
these two are
exactly.
same. Yes, perfect.
Yes.
I think
So the outer shape is a rectangle now that we can say.
yes.
Inner shape is also a rectangle. I have no doubt about it.
Yeah, that is what even I feel. I mean, we have to take exact measurements, but still, it looks like a rectangle.
I'm wondering if this rectangle hole is similar to like the original starting rectangle and like the
That
bottom.
is what we have to see. The ratio of length
Oh.
is great. That is what you are saying, right? Yeah. Because for square, it has to be same. So every square is similar. But in rectangle, there it is another question that we can explore. So what will be the area of bigger rectangle, outer rectangle, and then area of this? If you subtract this area, then it should match with the original area, right?
Yeah. So the whole plus the area of original rectangle will be the area of this new outer rectangle.
Yeah, the area of this outer rectangle, including this, the whole, and then we'll subtract area of the original square or rectangle, whatever we started with, then it should match.
Yes, correct. Still, what are the open questions? For me, I have not figured out why that hole is a square and why the rectangle is giving another rectangular hole, and if there are some common properties among the rectangles also.
Yeah.
Yeah.